Learning Made Easy. I am Nabiha and we're going to continue with part 2 of organic chemistry. So we're going to look at properties of alkanes. So the first property is they are non-polar. This is mainly caused by the covalent bonds, right? And then it's insoluble in water. Because it's non-polar, it cannot be soluble in water. Next, it is insoluble in polar compounds. An example is ethanol. Alright? And lastly, we look at melting point. We look at melting point and boiling point. So basically, boiling point deals with liquids. Alright? This is basically the energy needed to break the forces of attraction. So amongst all the alkanes, there are small forces of attraction, right? These are also known as London forces. Right? So for boiling point, this is the energy required to break the London forces. Okay? And one thing you need to know about melting point and boiling point is, as molecular weight increases, the boiling point and melting point also increase, right? And then when we look at branched alkanes or branched compounds, as branching increases, melting point and boiling point decreases. Why? This is mainly because when an alkane is branched, let me give you here. Okay, so this is what? This is 2-methyl propane. We'll look at naming them in just a second, but let me just demonstrate this. And then we have CH3. Okay, so this is butane. If you look at the two compounds, they generally have the same molecular weight because this compound has 4 carbons and so does this one, and this one has the same amount of hydrogens and so does this. But the only difference is this is a branched alkane. Why? Because we have a substituent group, which is the methyl, right? This one, alright, and it's making the chain shorter compared to that. So this makes the surface area smaller compared to this. This one is a long line and this one is a shorter one. Alright, so as branching increases, the surface area becomes smaller, therefore the melting point and the boiling point increases. It's important to note that for this, they should have the same molecular formula, they should have the same molecular weight. Alright, when it comes to this. So now let's move to naming the compounds. Alright, so one thing you need to know is that the general formula for alkanes is CnH2n plus 2. Alright, and remember we said they have the suffix A and E. Alright, so when we have N being 1, we have the prefix meth. Alright, and when you add A and E, we get methane. Alright, and when you substitute 1 into the formula, you get C1H4. We don't usually write the C1, but it's written as CH4. When N is 2, we have the prefix F, and it has the formula this. You can pause the video for a second and try and copy this table. It will help you. One thing, however, you do need to know is from 1 to 10. When N is 1 to N is equals to 10, you should be knowing the names and the formulas, alright? So I'll leave this for you. You can finish copying this and filling the table. Maybe I do one with you. So this one will be propane. Alright, and this will have the formula. When you put 3 into there, it will be C3H. 3 times 2 is 6, plus 2, that's 8. So the formula for propane is C3H8. Alright, so that is how we name alkanes. Alright, by the way, these are straight. These are for naming straight chained alkanes. Remember, here we did butane and 3-methylpropane. So this one is a branched alkane and this one is a straight chain. So you see, butane is when C is 4, because 1, 2, 3, 4, and it's here but, and when you add there, it will be butane. Alright, so now that we have that, we're going to look at how to name branched alkanes. Okay, so one thing you need to know, what are branched alkanes? Branched alkanes are straight chained alkanes, these ones, with a substituent group attached to them. Alright, they are straight chained alkanes with a substituent attached to it. But what is a substituent group? Right? So a substituent group can be an atom or a group of atoms that are attached to the parent chain. Alright, so this straight chain is referred to as the parent chain. Okay, and one thing you need to know, that a substituent group usually has the suffix YL, Li. Alright, so the substituent can either be an alkyl group, and an alkyl group is basically an alkane that has lost a hydrogen atom. We'll look at that in this table here below. Or it can be a halogen. What is a halogen? These are the elements in the periodic table group 4, the last group. This is chlorine, iodine, bromine. Alright, so looking at what an alkyl group is, we have methane. An example of an alkane is methane. Alright, so for it to become an alkyl group, it needs to lose a hydrogen atom. So here we looked that methane has the formula CH4. If it loses a hydrogen, it becomes CH3. Alright, so when it loses a hydrogen, like here, this is it becomes methyl. Alright, remember, alkanes have a suffix A and E, and we know that an alkyl group has a suffix YL. Alright, so we remove, if it was methane, we remove the A and E, alright, and we put YL. This becomes a methyl. Alright, let's do another example. If we have ethane, alright, for it to be an alkyl, if we remove the A and E and we put YL, it becomes an ethyl group. And its formula, we know that methane has the formula C2H6. So for it to be a methyl, we said we reduce the hydrogens by 1. So this becomes C2H5. So I have this table over here. I've just done 3. I've done for methane, ethane, and propane. You can do butane, pentane. Alright, you can finish the table, and if you want, you can extend and write the formula for the alkyl group. Okay, so I have an example here of a branched alkane. Alright, so this one is known as 2-methylpropane. Right? Why? Because the substituent group is joined. This is the parent chain, alright, because it's the longest straight chain. Alright, and where is it? It's on, this is the first carbon, this is the second carbon, and this is the third carbon. Alright, so you find the methyl group is attached to the second carbon on the parent chain. This one is the parent chain. So that's where you get the name 2, meaning where it's found. It's found on the second carbon, and then it's a methyl group, so you write methyl. And what's the name of the parent chain? Propane. So we get the name 2-methyl propane. Alright, I'm going to take you through step by step on how to name them, but what the important things you need to know? You need to know the parent chain. 1. The parent chain. 2. You need to know the substituent group. Alright, you need to identify, is it a halogen or is it an alkyl group? Alright, those are the 2 most important things you need to know. Alright, so let's look at the steps on how to alkane. So I'm going to take you step by step on how to name this. So the first step, you need to identify the longest continuous parent chain. Alright, so you need to find the longest and most continuous. Alright, so if you look at this one, it's 1, 2, 3, 4, 5. Alright, 1, 2, 3, 4, 5. This is the longest parent chain, and we saw from this table that when n is equals to 5, the prefix is pent, right? So that means our parent chain is going to be a pentane. Alright, that's the first thing. Secondly, we're going to number the parent chain from the side closest to the substituent group. I'm going to rub these numbers, right? One thing you need to know is when numbering the parent chain, you should always give the substituent the lowest possible number. Alright? Because if we number from this way, this one is going to be 1, 2, 3, 4, 5. Alright? This means that the substituent group, meaning the methyl, is on the 4th carbon. Alright? But if we name going this way, 1, 2, 3, 4, 5. Numbering this way, it shows that the substituent group or the methyl group is on the 2nd carbon. 2 is less than 4. This means it's giving the methyl group the lowest possible position, lowest possible location. Alright? So now that we have identified, so this one is basically wrong and we're going to go with the bottom one. So we've identified it's on the 2nd carbon. So we write here 2nd. Alright? Or you can write 2-methyl. And then the third step, if there is only one substituent group present, you have to locate it, which we have done. We found it's on the 2nd carbon, and attach its number to the name of the parent chain. Alright? So we're going to join these two together. We're finally going to get the name of this alkane. Alright? So first you put the substituent in front of the name of the parent chain. And always remember, numbers are separated from words with a hyphen, with a dash, and numbers are separated using commas. Let's say if we had another methyl group up here, CH3. This would mean there are 2 substituent groups and they're both on the 2nd parent chain, so we would say 2, 2. Alright, but for now let's deal with this. See here, we have 1, so we put the 2 dash because we're separating words from numbers, methyl, because the substituent is a methyl group as we identified before, and then pentane. And always remember that when you're attaching the parent chain, the name of the parent chain, don't leave a space, you join it. So it's 2-methyl pentane, not 2-methyl pentane, it's 2-methyl pentane. Alright? So let's look at if we have more than one substituent group. Let me give you an example here. CH3, CH3, CH4. We said first thing we need to do is identify the parent chain, right? So we're going to count how many carbons are straight. Alright, so we have 1, 2, 3, 4, 5. If you count starting from number 1 here, it will be 1, 2, 3, 4, 5. And if you start counting from here, it will be, let me write this as, this can be written as CH2, CH3. Alright, so if we start counting from here, it's 1, 2, 3, 4, 5, 6. Did you see? 1, 2, 3, 4, 5, 6. Notice the mistake. If you didn't open this, you would name the parent chain as a pentane. 1, 2, 3, 4, 5. But because we opened this, we've identified that the longest continuous is actually when 6 carbons. And from this table, we saw when N is 6, it's a hex, meaning the parent chain is a hexane. Alright? And then we have to identify the substituent groups. And one thing you need to know when there are 2 substituent groups, now that we've identified, let me bring it back to C2H5. Alright? We need to identify the substituents, and when there are 2, you name them alphabetically. Alright? So this one is a ethyl, right? Because it's an ethane but has lost 1 hydrogen. And this one is a methyl group. Methyl. Alright? Following the alphabet, E comes before M. Alright? So we're going to give priority to this. Alright? So, sorry. Yeah. This one. My mistake. Let me CH2, CH3. If we're going to number, it's going to be 1, 2, 3, 4, 5, and 6. That's our parent chain, right? So that makes, if we're going like that, we have here. This one becomes our substituent group. I actually made a mistake. I apologize. Alright? It's going that way. So that makes this our substituent group and this our substituent group. Why has it changed? Because we've changed the way the parent chain is moving, right? So that means we have a methyl group here and a methyl group here. Alright? So if we count from here, starting from this side, we'll find one of the methyl group is on 5, right? And here it's on 3. Okay, because if they are the same, we don't. We just count. Remember, this has 2 carbons, so 1, 2. If I open this, it will be CH2. Alright? So this is when we've opened it. Okay? So if we count from here, it will be 1, 2, 3, 4. Alright? And if we count this way, 1, 2, 3, 4, it's still the same thing. Alright, so I'm going to take this as my parent chain. 1, 2, 3, and 4. Alright, this is going to be my parent chain. Okay, so we have this one is an ethyl group. Okay, and this one is a methyl. Okay, so when we're numbering the parent chain, we give priority alphabetically. Alright, if you look at this is an E and this is an M. Okay, so E comes before M according to the alphabet. If you do A, B, C, D, E, F, G, you'll see E comes before M. So we're going to give this ethyl group the smallest possible number. So looking at that, we're going to start counting from this side. 1, 2, 3, and this is going to be our 4th one. Alright? So we've identified that our chain is a bute, right? Because it has 1, 2, 3, 4. So it's a butane. And we have an ethyl group on carbon number 2 and a methyl group on carbon number 3. So we're going to start with this, and it's on carbon number 2, so that becomes 2. Remember a dash. Then we have ethyl, right? And then 3, because it's on the 3rd carbon, dash, methyl, propane. No, it's a butane. Butane. And that's how we name a branched alkane with 2 or more substituent groups. Done.